Okay, we're going to talk about chapter 7.2, which is matrix algebra. And the first thing we want to talk about is adding two matrices. In order to add matrices, there's a couple things that have to happen. Number one, your matrix have to be of the same order. Okay, which is their size. Okay, so they have to be this. There has to be the same number of elements in each one. Also, with subtraction, they got to be the same size. And second, in order to add, you're just going to add the corresponding elements. And in subtraction, you're just going to subtract corresponding elements. Okay, so let's say I have a matrix here. Let's just say it's 1, 3, minus 1, 5, plus this matrix here. Okay, if I have those two matrices, I can't add them. Okay, this I could add here, and this one I could add here, but when I get to this column, there's nothing to add it over here. So if we add some numbers over there, now we can add them. And when we do this, we take this element plus this element. These are both in the same location. So we will get 2 then. Okay, then we go to -1 plus 2. We go to 3 plus -2. We go to 5 plus 5. Now notice when I add them, I had a 2 by 2, a 2 by 2, and then I ended with a 2 by 2. That will always happen. Whatever order you start with, you will end with. We can do the same kind of thing with subtraction. Okay, so they're the same size. They're both 2 by 3. And when I subtract, I should get a 2 by 3. So that's one way you can check yourself real quick. So you have 1 minus 4. And notice they go in the same location after your subtraction. 3 minus 5, 5 minus 6, -3 minus 0, 2 minus 1, and 1 minus 2. Okay, and again, I have a 2 by 3 matrix there. So that's addition and subtraction. You're just adding and subtracting whichever one goes along with the other one. We have matrix equality. Okay, and the first thing with that is, again, they have to be the same order. Okay, they got to be the same size. And in this case, when we're setting two matrices equal to each other, each element is equal to one another. Okay, so the elements are equal. For example, if I get something like this, okay, now since these two matrices are equal, then each corresponding element has to be equal. So you'd say something like 2x equals 6, y minus 1 equals 7, 1 equals 1, and 2 equals 2. So these are good. Here, x would be 3, and y would be 8. And that's all you're doing there. Now, the hard one is multiplication with matrices. We have scalar multiplication, which is just a number. Okay, that's saying like if I have -2 and then my matrix 1, 2, 5, -3. Okay, this is the scalar, okay, which just means I'm sizing this matrix up. I'm blowing it up, okay, or making it really small. So we're just going to take this and we're going to take it to every element in here. So to the 1, to 2, to the 5, and to the -3. And we're going to multiply. So we'll get -2, -4, -10, and 6. And that's it. It's kind of like the distributive property. You're just taking it to every element inside there. Now, when you multiply two matrices, okay, there's one super, super important rule. Okay, and we base it on the order. Okay, so I'm going to say check order. That's important. Okay, so let's say I have this matrix. Let's say I have these two matrices. Okay, the order of the first one is a 3 by 1. 3 rows, 1 column. The order of this one is a 1 by 2. Now, when you multiply, you need to check the order in the direction that you're multiplying. And these two numbers, okay, so the columns on one has to be the same as the rows in the other one. If they are the same, you can multiply. If they are different, you cannot multiply. And the other two numbers is the size of your new matrix. Okay, that's the size of your new matrix. So it'll be a 3 by 2. Your new matrix. Okay, so I just want to try one here real quick. Let's look at okay, so this one is a 2 by 2 matrix, and this one is a 2 by 1 matrix. So since these two numbers right here match, we can multiply, and this will be our new matrix. So it'll be a 2 by 1 matrix. Okay. Now, how do I get into multiplication? Super easy. Okay, let's say we want to multiply these two together. We're going to set up a little table, and the first matrix is going to go down here in the bottom left. The second matrix is going to go up here in the top right. Okay. So now our new matrix will be right down here. Okay, this up here is for only scratch work. So we'll have 4 elements here. So 1, 2, 3, 4. To get this element, we want this row and this column. 2 by 1. So this row and this column. So we're going to take these two numbers and these two numbers and multiply them. So we get 2 and 3, and then we add in this direction. So that makes 5. When we come down here, we'll do this row and this column. So I'll take, that's 3, that's 15, and we will add those two together to get 18. So my new matrix will be a 5, 18 matrix. Okay. I'll do some more examples of those. You can stop here. Your questions. What has to happen in order to add or subtract matrices? What has to be true in order to multiply matrices? And then I want you to try these 3 out right here. there's your suggested problems. You should know enough to get you going. I got about like 10 more minutes of recording. So. All right, let's do some examples. So we talked about adding real quick. Let's do that one and this one. Okay, and we want to take, add those together and then subtract them. So we can, because they're the same size. So if we add them, okay, we're going to take -1 plus 2, take 3 plus 1, 4 plus -3, -5 plus 0, 2 plus -5, and 0 plus 4, and that's it. Okay. When we subtract, okay, and a lot of times the problems will say like that's matrix A, that's matrix B, find B minus A. Okay, so we got to make sure we go in the right order. Okay, so B minus A, so that's 2 minus -1, 1 minus 3, -3 minus 4, 0 minus -5, -5 minus 2, 4 minus 0. Okay, so you have to be very careful when you do that kind of stuff because it's simple math, but very easily messed up. All right, let's look at a couple multiplication problems. So let's look at this one. So there's A, here's B. Okay, and we're going to take 2 times the A matrix. So we're just going to take 2 times every number in there. So -2, 4, -6, 8, minus, and then we're going to take 3 times everything in your B. So it's 0, 3, -6, 9. And now we're going to subtract these two matrices, which I can do because they are the same size. So you have -2 minus 0, 4 minus 3, -6 minus -6, 8 minus 9. And there's our answer. Okay, if we try, so that was scalar multiplication. If we try just some normal matrix multiplication, all right, let's take these two and multiply them. Okay, so this is 2 by 2. This is 2 by 2. So these inside two numbers are the same, and I will end up with a 2 by 2 matrix. So if we set it up, the first matrix goes in the bottom. The second matrix goes in the top. Okay, and I will have 4 elements down here. So to get this first element, I use this row and this column. We'll multiply across, so you get 5 and 14, and then you add coming down into this box. So you get 19. And then here we'll multiply and get 16. We'll multiply and get 6, and we'll add. Okay, then we take 3 times 5, which is 15, plus 4 times 7, which is 28. You get 43 there. and then you'll multiply 3 and 6, multiply 4 and 8, and then add those together. So our new matrix looks like this: 19, 22, 43, and 50. So multiplying matrices is really nice for some word problems. So if we're given this table here, okay, so we're comparing 3 different types of cars. Okay, so this is number of gallons per mile. And then kilowatt hours, so how much electricity. So, and then we have cost. So $3 for gas, and then 5 cents per kilowatt hour. So we can see which car is going to be most effective depending on these amounts right here. So what we'll do is we'll just set them up in a matrix, which they already kind of are. And we'll just multiply them together. Okay, so there's what I'm going to multiply together. Again, our first matrix here goes down here. And then our next matrix, we'll just change that to a 3, and then 0.05 goes there. So we're going to multiply, add. So we have 0.15 in my first one. We're going to take 0.02 times 3 and 0.1 times 0.05. You get 0.065. And then 0 times 3, 0.25 times 0.05. And then we have those numbers. Now, what those numbers tell us is that this is the cost per mile to drive each one of those vehicles. Okay. And this is per a certain time. I think this was like weekly or something like that. So we could figure out how much in 1 year it would be beneficial. Again, here's your suggested problems. Get working on those. If you got questions, let me know. This is at THS Mr. Jones signing off.